Next is column matrix match. So let us solve it. A fair coin is tossed 10 times. Then option number P says that we have to find the probability of getting at most 3 heads. At most 3 heads means either it will have 0 head, 1 head, 2 head or 3 heads. Now probability of getting 0 head is 10C0 into 1 by 2 raised to the power 10 plus 10C1 into 1 by 2 raised to the power 9 into 1 by 2, that is again 2 raised to the power 10 plus 10C2 divided by 2 raised to the power 10 plus 10C3 divided by 2 raised to the power 10. So solving this, we will get it equal to 176 divided by 2 raised to the power 10. So which means that P matches with option number 5. Now next let's solve Q option, which says that the probability that third head appears in 7th toss, which means that in first 6 tosses we need 2 heads. Now let's select first 6C2 into 1 by 2 raised to the power 2 into 1 by 2 raised to the power 4. These are 4 heads, these are 4 tails. Now for 7th toss, by 1 by 2 probability, I want it to be head. Now in the rest 3 options, it can either be head, it can either be tail. So its probability will be 1. So solving this, we will get it equal to 120 divided by 2 raised to the power 10. That is, it matches with option number 3. Now next is R option, which says that the probability that no 2 consecutive tosses result in head, right? Now in this case we can have how many heads? Either we can have 0 head or 1 head or 2 head or 3 head or 4 head or 5 head. We cannot get more than 5 heads because then it will become consecutive. Now for 0 head, the probability will be 10C0 divided by 2 raised to the power 10. Now for 1 head, it can be anywhere, that is 10C1 divided by 2 raised to the power 10. Now for 2 heads, let us solve it by gap method. Let's say 2 heads come here. So in between these 2 heads, we have x2 number of places. Before h I have x1 places and after h I have x3 places. So we can say that x1 plus x2 plus x3 is equal to 10 minus 2, that is 8, and here x2 should be greater than equal to 1, x1 and x3 should be greater than equal to 0. So we can say x1 plus x2 dash plus x3 should be equal to 7, where x2 dash is also greater than equal to 0. So its number of integral solutions will be 7 plus 3, that is 10, minus 1, that is 9C2. So for 2 heads, the solutions will be 9C2 divided by 2 raised to the power 10. Similarly, we will find for 3 heads, and it will be 8C3 divided by 2 raised to the power 10. For 4, we will have 7C4 divided by 2 raised to the power 10, and for 5, we will have 6C5 divided by 2 raised to the power 10. So to find the total probability, we have to add all these cases. So adding all these, we will get it equal to 144 divided by 2 raised to the power 10. So it matches with option number 4. Now last one is option number S, that is, if head appears 5 times, then the probability that first 3 tosses result in head. It's a conditional probability. Let us say A upon B, where B says that head comes 5 times and A says that first 3 tosses results in head. So it will be equal to probability of A intersection B upon probability of B. So this will be equal to, now in first 3 we want head, so that will be 1 by 2 raised to the power 3 multiplied with, in the rest 7 tosses we want 2 heads, that is 7C2 multiplied with 1 by 2 raised to the power 7 divided by probability of getting 5 heads, that is 10C5 multiplied with 1 by 2 raised to the power 10. So this will be equal to 7C2 divided by 10C5. So that will be equal to 1 by 12. So it matches with option number 2. So correct option is option number D. So answer of this question is option number D. Next is question number 52. Here alpha is given as an integral cos x dx divided by sin cube x plus cos cube x. Beta is equal to limit n tending to infinity multiplication of r equal to 1 to n cube plus r cube divided by n raised to the power 3n whole raised to the power 1 by n, and mu is also given to us. Now option number P says that mu minus k alpha is equal to 0. So let's find alpha here, that is equal to 0 to pi by 4, dividing the numerator and denominator by cos cube x. So we will get secant square x into dx divided by 1 plus tan cube x. Here let's take tan x equal to t. So secant square x into dx will be dt. So the integral will go from 0 to 1. Now here it can be seen that it is equal to mu, which means that alpha minus mu is equal to 0. That is value of k is 1. So 1, that is given in option number 2. Now next is option number Q. So let's find the value of ln beta here, that is equal to limit n tending to infinity, taking ln 1 by n can be taken out, so it is equal to 1 by n into, now here it is n raised to the power 3n, so we have n terms, so n cube can be given to each term, that is we can write it as summation r equal to 1 to n ln of 1 plus r by n whole cube, right? Now here converting it into integration, it is equal to ln of 1 plus x cube into dx, where x is going from 0 to 1. Now solving it by parts, it will be equal to x into ln of 1 plus x cube, limit is from 0 to 1, minus integral of x into 3x square, that is 3x cube divided by 1 plus x cube into dx from 0 to 1. So this is equal to ln 2 minus 3 times integral of adding 1 and subtracting 1. We will get 1 minus 1 upon 1 plus x cube into dx from 0 to 1. So this is equal to ln 2 minus 3 times x, that is 1. So this will be minus 3 plus 3 times integral of 0 to 1 dx upon 1 plus x cube, that is mu. So comparing it with ln a, that is a is 2 minus 3 plus b mu, that is b is equal to 3, which means that value of a plus b is 5. So it matches with option number 6. From here only we can see that option number A is correct. But still, let's solve other options also. Option number R, in which we have to find mu. So mu is equal to integral from 0 to 1 dx upon 1 plus x cube, that is a cube plus b cube, can be written as 1 plus x into 1 plus x square minus x. So this is equal to, by partial fractions, we can write it as 1 by 3 into x plus 1 into dx from 0 to 1 minus 1 by 6 times integral of 2x minus 1 minus 3 divided by x square minus x plus 1 into dx from 0 to 1. So this is equal to 1 by 3 into ln of x plus 1, that will give me ln 2 upon 3 minus 1 by 6 into ln of x square minus x plus 1 plus 1 by root 3 into tan inverse 2x minus 1 upon root 3, where the limit is from 0 to 1. So solving this, we will get it equal to 1 by 3 times ln 2 plus pi by root 3, which means that the value of a is equal to 2 and the value of b is equal to 3. So the value of 2 into b, that is 6 upon 2, that is 3, which means that option number 4 is correct. That is what have been given in option number A. Now, next we have to find the value of ln 4 upon beta. That is, we have to find ln 4 minus ln beta. We already know ln beta in terms of mu. So, let's put its value. Ln beta is equal to ln 2 minus 3 plus 3 times mu. So, let's put the value of mu, that is equal to 1 by 3 into ln 2 plus pi by root 3. Cancelling 3, we will get it equal to ln 2 plus ln 2, that is ln 4 minus 3 plus pi by root 3. So value of ln 4 by beta will be equal to 3 minus pi by root 3. So the value of greatest integer of 3 minus pi by root 3 will be equal to 1. That is, answer is option number 2. I hope the question is clear to you. Let's now discuss question number 53, which says that we have to match list 1 with list 2. A question on complex numbers. So let us solve it. Option number P says that if modulus of z r minus r is less than equal to r, for r equal to 1, 2, 3, 4, we have to find the maximum value of modulus of z1 plus z2 plus z3 plus z4. Now, modulus of zr minus r, that is less than equal to modulus of zr minus modulus of r is less than equal to r. So, modulus of zr is less than equal to 2r. Now, modulus of z1 plus z2 plus z3 plus z4, it is less than equal to mod z1 plus mod z2 plus mod z3 plus mod z4. That is, it is less than equal to 2 times r1, that is 2 times 1 plus 2 plus 3 plus 4. So this is less than equal to 20, which means that its maximum value is 20. So option number 4 matches with it. Now, next is Q option, which says that if modulus of z1 minus 2 plus modulus of z1 plus 2 is less than equal to 8, that is, it is an ellipse, and modulus of z2 minus 4 is less than equal to 2, so we have to find the maximum value of 2 times mod z1 minus z2. Here we have to draw the curves. First is an ellipse where the foci are 2 and minus 2, and 2a is equal to 8, which means that a is 4. The second curve is z2 minus 4 modulus less than equal to 2, which means that it is a circle with center at 4, 0 and radius 2. So it will pass through this point. Now, we have to find the maximum value of mod z1 minus z2. That will be when z1 is here and z2 is here. So, z1 minus z2 will have maximum value equal to 6 minus 4, that is 10. Maximum value of 2 times of this will be 20. So answer is again option number 4. Next, let's solve option number R now, which says that z1 and z2 are two complex numbers satisfying both the equations. Two equations are given which are circles. Then we have to find 2 times mod of z1 minus z2 whole square. So both of them are circles. Center of one is 1, 1 and center of the other one is minus 1, minus 1. By distance formula, the distance between two will be 2 root 2, and the radius of first circle is root 2 and the radius of second circle is 2 root 2. So let us join it, because we have to find z1 minus z2 mod whole square, that is this point is z1 and this point is z2. Let us say mod z1 minus z2 is equal to L. So this distance is L by 2. Now let us say these points are O, O dash, M, N, and this is P. So here we can see that firstly let's find O dash P, that will be equal to, in right triangle O dash PM, it will be equal to 8 minus L square by 4 under root, right? Similarly, let's find OP, that will be equal to under root of 2 minus L square by 4. Now by distance formula we can find OO dash, that is we have already found 2 root 2 is equal to root of 8 minus L square by 4 plus under root of 2 minus L square by 4. So squaring 2 times we will find the value of 2L square equal to 15, which means that the required value is equal to 15. So answer will be option number 2. So from the given options, let us check. Our answer will be option number C, but still let us solve option number S now, which says that mod z1 is 3 and z2 is equal to 5 minus 12 iota. Then the least value of modulus of z1 minus z2 is. We know that mod z1 minus z2 is always greater than equal to modulus of mod z1 minus mod z2. So it is greater than equal to 3 minus 13 mod, that is it is greater than equal to 10. So answer will be option number 1. So we can say that option number C is the correct choice. Next is question number 54, which says that let f going from R to R and fx is 2 into x raised to the power 4 plus ax cube minus 6x square plus ax plus 2. Option number P says that if fx is equal to 0 has at least 2 distinct positive roots, then we have to find the exhaustive set of values of a. See, the given function fx can be written equal to, if we multiply and divide by x square, we will write x square multiplied with 2 times x square plus 1 by x square plus a times x plus 1 by x minus 6. Now if we put fx equal to 0 and put x plus 1 by x equal to t, so we can write it as 2 times t square minus 2 plus at minus 6 equal to 0, that is 2t square plus at minus 10 equal to 0. Let us assume it as gt equal to 2t square plus at minus 10. Now option number P, that is gt should have at least one root greater than 2, because t equal to x plus 1 by x is either greater than equal to 2 or less than equal to minus 2. So let's solve it. Let us say this is the function, because g of 0 is minus 10. Now we want root greater than 2, which means that g of 2 should be less than 0, right? So putting it here, we will get 8 plus 2a minus 10 is less than 0. That is 2a is less than 2, that is a is less than 1. So from the given options we can see that minus infinity to 1, that is given in option number 2. Now Q says that fx equal to 0 has 4 real and distinct roots, then the exhaustive set of values of a is. For 4 real and distinct roots, gt should have one root greater than 2 and one root less than minus 2. That is, the graph should be something like this, which means that g of 2 should be less than 0 and g of minus 2 should also be less than 0. This we have already found. Let's find g of minus 2 less than 0. That is 8 minus 2a minus 10 should be less than 0. That is 2a should be greater than minus 2. That is a should be greater than minus 1. So taking intersection of a greater than minus 1 and a less than 1, we will get a belongs to minus 1 to 1. that is given in option number 1. Now, option number R says that fx equal to 0 has no real roots, then exhaustive set of values of a is, for no real roots, either gt should have imaginary roots or both the roots should be between -2 to 2, right? Roots should be between -2 to 2. We have two options here. Now, for imaginary roots, discriminant should be less than 0. Here, discriminant is a square plus at, but that is always greater than 0. Hence, imaginary roots are not possible. Now, another requirement is that both roots should be between -2 to 2. For that, g of 2 should be greater than 0 and g of -2 should also be greater than 0. But that will give me a greater than 1 and a less than -1. So from here also we don't get any interval of a, which means that a belongs to phi. So option number 5 matches with it. Now, option number S says that g of x comma a is equal to fx upon x square, then the minimum value of g of x comma 0 lies in fx upon x square, that is equal to 2 into x square plus 1 by x square plus a into x plus 1 by x minus 6. This is fx upon x square. Now here we have to put a equal to 0. So this will be 0. So it is equal to 2 times, making its perfect square, x plus 1 by x whole square minus 2. So that will be equal to -4 minus 6, that is -10. So we have to find the minimum value of this. Now the minimum value of x plus 1 by x whole square is 4. So the minimum value of the required function will be 8 minus 10, that is -2, which is lying in the interval -infinity to 1. So option number 2 is correct. So we can say that answer of this question will be D option. I hope the question is clear to you and all the queries have been solved. Thank you for watching.